Hi there folks, today we will continue with the final part of the simple machines, which includes wheel, axle and gears. Since almost every mechanical systems are based on these elements, let me give you some information what we will do today and then start the lesson. First, I will do very short definitions of wheels and gears, then solve a few examples. Finally, I will show you a 5-minute video about combination of wheels and gears. The footage explains the working principle of differentials, which used by almost every vehicles on Earth. It also explains how an automobile goes, what makes it running. This video will have a very beneficial effect on people who watch the video because the working principle of differential is so exquisite, magnificent and very simple at the same time. Before beginning the wheels and gears, let me tell you this. In order to gain mechanical advantage, the power is given into smallest wheel or smallest gears all the time, which is called driver. And the power transmitted into bigger wheel through strap or through tools in gears. So that we call that driven or load. So let's start with wheels. The purpose of using wheels and gears are controlling the speed and direction. The system consists of at least two or more than two wheels which connected with a strap, as you can see, with a strap or belt. As you can see, these two wheels are connected to each other with a strap. And we usually use wheels or gears are change the direction or speed of the rotation. Let's say this driver wheel turn to the counterclockwise. Also the bigger wheel will be rotate to the counterclockwise. And the formulas are quite basic and easy. The bigger end represents the number of rotations of the bigger wheel and the smaller end represent number of rotations of the driven wheel. And the bigger R, as you can see, the bigger one, the smaller R represents the smaller one. Okay, let's look at the example in wheels. Okay, we have two wheels connected with a strap and the number of rotations are given except the smallest one and radiuses are also given. So what was the formula? The formula was the number of rotation of the bigger one divided into the smallest one and the radius of the bigger wheel divided by the radius of the smaller one. This was our formula. So here I'm trying to find the number of rotations of this one, the smaller wheel. And this one is 4. I'm looking for this one. And R is equal to 10 centimeter and smaller R is equal to 5 centimeter. So from here I can find the smaller n as 4 divided by n is equal to 10 centimeter divided by 5 centimeter. And from here I can find 4 times 5 divided by 10 and that's equal to n. So n is equal to 2. That means that if I rotate the smaller n 2 times, that means the bigger wheel will turn 4 times, which is given in the question at the beginning. Okay, so how we can find the mechanical advantage of this one? The mechanical advantage in wheels are equal to bigger R divided by smaller R, or the bigger N divided by the smaller N, which is 10 centimeter divided by 5 and that's equal to 2. The mechanical advantage is also 2 in this example. So let's continue with the gears. As I just mentioned at the beginning of the subject, the small gear is called driver. This one is driver or effort, and the big gear is called as driven in gears. And this is our formula. Number of the teeth, number of the rotations again, and this one is represent number of rotations, and this one is represent the number of teeth. The gears, we use gears usually, the direction of the rotation of the driving gear is always the opposite. If I rotate the driver gear in this way, so that means the bigger gear will rotate the other way. We can calculate the mechanical advantage of gears by using this formula again. Basically, wheels and gears have the same working principle. The only difference between wheels and gears is that the direction of the rotation of the driving gear is always opposite of the driver gear. This one I just explained. So let's look at the example. You see, we have two gears here, the smaller one and bigger one. So the formula was N, the big N, divided by the small n, which is equal to smaller rotation of the driver gear divided by the rotation of the bigger gear. So that one is our formula. In the question, we are looking for the rotation of the smaller gear. This one is given as 20, and this one is given as 12, and that one is 3. So let's calculate together. So from here I can find this one as 20 times 3 divided by 12. And from here I can find 20 times 3 is 60 divided by 12, and that's equal to 5. That means that if I rotate the smaller driver 5 times, the bigger gear will be rotated only 3 times. Okay, we came to the final part of our lesson today. Let's see how differentials work. I'm quite sure that this video will enlarge your horizon significantly. If you have any questions, please do not hesitate to make comments on this video and like the video. Now let's see the footage.
If two wheels are locked on an axle so that they are not free to turn separately, one or the other has to slide. So engineers had to find a way to connect both rear wheels to the engine without sliding and slipping on turns. The device which makes this possible is a part of the rear axle. It is called the differential because it can drive the rear wheels at different speeds. The differential looks complicated, but once we understand its principle, it is amazingly simple. These two wheels are mounted on separate axles and supported by a frame so that they can revolve freely at different speeds. Let's fasten a spoke on the inner end of each axle so that by turning the spokes, we can turn each wheel separately. With a bar or crosspiece, we can turn both wheels in the same direction at the same rate of speed. Let's get something to hold this bar in place so that it will press against the spokes. Notice that this support is not locked to the axle. It turns freely. Now, we can spin the wheels by rotating the support. This is fine, as long as both wheels are able to turn at the same speed. But let's see what happens when we go around the corner. With this arrangement, we cannot drive one wheel faster than the other. And if we stop one wheel, the other wheel won't budge. Let's put this bar on a pivot so that it can swing in either direction. Now, the bar can still turn both wheels at the same speed. And because it pivots, it lets one wheel turn even when the other is stopped. But if turned too far, the bar will swing around until it won't drive the spokes that turn either wheel. We need another crossbar and more spokes to carry on the job. When we stop one wheel, the crossbars will continue to push the spokes of the free wheel around. As long as both wheels are free to turn, the bars do not swing on their pivot, and the wheels move at the same speed. Now we have the working principles of a differential. To adapt the model for use in an automobile, we will have to make a few changes. In order to reduce the jerky action caused by wide spaces between the spokes, we will put in more spokes. Further filling in the spaces between the spokes gives steadier, more continuous action, and changing the shape gives firm, constant contact. Now we can make the gears thicker and stronger, and we have differential gears. The edges are cut so that they will fit together more smoothly and silently, and another gear is added to share the work of driving the axles. The principle is the same. In order to turn the support and drive the wheels, we can fasten a large gear here, connected by a smaller gear to a source of power. Notice that the power is connected to the differential at the center line. We can make our model more compact by moving the gears closer together. When we put our differential in an automobile, we have to leave room for the drive shaft, which carries the power from the engine. We may build the floor of the car above the drive shaft. But if we do, we won't have much room inside unless we make the top of the car high too. Of course, we could lower the floor and ceiling, but the drive shaft would be higher than the floor. This would have disadvantages. A shaft in the middle of the floor of an automobile would be inconvenient for passengers and would be awkward for carrying luggage. Today, engineers have found a way to make the car roomier and closer to the road without a clumsy shaft above the floor. The drive shaft from the engine to the differential is lowered out of the way, and the drive shaft is connected to the rear axle at the bottom. The new low-center drive makes the rear axle quieter, stronger, and more durable because it gives better, smoother contact between the gears. The automobile of today, with the low-center drive, is stronger and more rugged.